In this video, I'm going to explain how we do Sig Figs in physics. This document is currently in Google Classroom. You'll see it there. You can ask me, and I will post it there so you can access it. But you can read through this, but this is just a quick summary of each of these rules. So first of all, the first rule is that if it's not a 0, it's a Sig Fig. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all those digits are Sig Figs. So that's why this one has 3, and the next one down has 4, and the one below that has 5 Sig Figs, because they're all non-zero digits. Doesn't matter if they're before or after the decimal, they're all Sig Figs. Second rule, if you have a 0 between two digits that are not zeros, what I call the sandwich rule, or the sandwich 0 rule, it's a Sig Fig. It's not just a spacer, it means it was measured that accurately, and it counts. So that's why these numbers come out as they do. Third rule, zeros to the left of a decimal or to the right of a digit are not significant unless marked with a bar. What does that mean? Okay, so the zeros in the first example, 500, are spacers. They push the 5 into the correct place. It's, if you remember back in elementary school, the 5 is in the hundreds place, so that means 500. Now, these zeros are just spacers to push it over there. You've got to have something there to take their place. But it doesn't indicate whether they're measured accurately or not. Was this 499 rounded to 500, or was it a lower number even, 300 rounded up to 500? We don't know the rounding, so the error is in the 5. Now, when we say 950, again, this is a spacer. It just pushes these in the right place. So if you imagine a decimal after the 500, the 950, and the 7 million, then those are spacers that push the digit into the correct place. Now, if we want to show that it's a Sig Fig, like in the 9,200,000 example, and we want to say, hey, we measured that to the nearest 1,000, then we put a bar over that 0. Now, in chemistry and other classes, including physics, you can write these numbers in scientific notation because any trailing numbers after the decimal place are considered Sig Figs, including zeros at the end, which is the next rule. Let's explain this one a piece at a time. First of all, the 0 in front of the decimal, to the left of the decimal, is never a Sig Fig. It's just there to make the decimal place show up. For example, if you had 0.23, somebody looking at that quickly might see it and make a mistake and mistake it for 23. The 0 out in the front says, hey, got a decimal here, you can't miss it. Nobody ever says, well, I'm 012 years old, or I'll be 018 next year. The 0 out in the front makes the decimal show up. Now, once again, if you have, in the first example, zeros right after the decimal place, those are spacers. In the first example, in number 4, the 2, 3, 4 are pushed over into the right place by the zeros between them and the decimal place. So those are not Sig Figs. They're spacers. You don't even put a bar over those because that would be ridiculous. It would be nonsensical. But sandwich zeros in the third example are considered Sig Figs, and zeros at the end are considered Sig Figs because that means you measured it to that accurately, or you measured it with that precision. So tenths, hundredths, thousandths, 10,000ths, 100,000ths. You measured that to the nearest 100,000th place, and it's that accurate. The last digit is where the uncertainty is, so those are all the Sig Figs. And remember, Sig Figs are all the numbers you know for certain plus one that's uncertain, which is why the trailing 0 counts. So in the fourth example down, all those 0 at the ends are Sig Figs. Never the one in the front and never the ones after the decimal place. And you should go ahead and do the next few problems to yourself, pause the video, and see if you're right, because I'm going to give the answers in 3, 2, 1, now. So example A has 4 Sig Figs, B has 2 Sig Figs, C has 4, D has 4, E has 3, F has 6, G has 5, and H has 2. If you have questions about that, come see me. Now, here are some very good examples that go through and show you how you work Sig Figs. What if I do something on my calculator and I'm looking to get 3 Sig Figs, but the answer only has 2? You put zeros on the end. That's example 3. Talks about that. Happens to divide out perfectly to 2. But if you need 3 sig figs because 45.2 and 22.6 both have 3, we have to tack on zeros at the end, which means you really did measure to the nearest hundredth of a meter per second accurately, or precisely. All right? And then the reasons for the rules for addition and subtraction follow it. So see me if you have any questions about those, but the basics of sig figs in a nutshell are yours now. Congratulations.